So I have something to show you. This is a hammer. You probably already know that. A hammer is a hand tool for driving nails. It's mostly just for pounding stuff. It's not really good at anything else. So in a lot of ways, a hammer is better at breaking things than fixing things. Don't worry, I'm not going to use a metaphor the entire talk, but I will for this. This is a hammer in CSS. It looks like somebody's selecting an element and just bludgeoning it with styles and specificity and important until it looks right. So it has a specificity of 131 if you count up the IDs, the classes, and the elements. By comparison, a single class is a specificity of 10. So it kind of looks like the person who wrote this was trying to override something. This is another sign that this is a hammer, the use of important. Whenever you see important all over the place in one style block, what you're seeing is the developer screaming at the screen, saying, just make it work. And of course, this all contributes to a cycle that we find ourselves in. When you look at an existing style sheet and it feels like too complicated to understand, you end up writing new styles because you're afraid you might break something if you modify CSS, or you're not even sure where all the styles live. And then when you add CSS, you close the loop and you add more complexity to the style sheet, making it even harder next time. So I think most of us have seen CSS like this, judging by the laughs. I think many of us have written CSS like this, and I'll be the first to tell you that I have written CSS like this. So who am I? You know, my name is Detrick, and I work for Meetup. What you may not know is that Meetup is 13 years old. So try to imagine what our style sheet has looked like over the years, given the fact that it only seems to grow. And we spent a lot of time trying to figure out how to keep our CSS under control. And we didn't really make any progress on this until we started asking ourselves questions like this. Why do we do it in the first place? Why do we resort to using CSS as a blunt instrument when it's an otherwise very powerful and expressive language? Well, this is one reason. It's definitely harder to read code than to write it. We know that. I think with CSS, though, it's especially difficult. And that's for a number of reasons, really. You got the quote, canonically. So this is a CSS fact. It's a rendering blocking resource. These are all the steps the browser needs to take in order to paint pixels to the screen. So in order to paint, you must first calculate layout, and to calculate layout, the browser needs a render tree. The render tree is constructed using the document object model and the CSS object model. The fun fact is that the CSS object model cannot be built until the CSS from the very first line to the very last line is completely downloaded and parsed. And that's because of the cascade. You can't resolve the cascade until you have all of the CSS. This is fine for a computer. A computer can do this. They're good at this stuff. Humans, not so much. It's hard just by reading the code to understand which styles are being resolved in the cascade where. What I'm saying is CSS is hard. Even though we have tools to help us with this stuff, when you're reading the actual code, it's hard to understand what's going on. And I think as programmers, we often focus on technical problems because that's what we do for a living. We write code, we solve code problems. But there are also human problems involved with maintaining CSS. This is my favorite computer science law of all time. It was written by Melvin Conway in 1968. It says, organizations with design systems are constrained to produce designs which are copies of the communication structures of these organizations. It's a lot to wrap your head around, but it was relevant then, and it's extra relevant now, especially with declarative language being one of the three main languages of the web. So in a concrete example, you often have three different teams working on different parts of a website or different parts of your product. They're essentially sharing the same style sheet because it's the same website, and because communication moves up and down through this structure very easily, but not laterally very well, you end up in a situation where it's very easy to create duplication. It's not just easy, but it's hard to get away from creating duplication. And when you have 12 different components that sort of do the same thing, but they're not quite the same, which one do you use? You know, they may not match your exact use case either, so it's just easier to write a new one. And of course, we also have deadlines. So if you don't have time to know what is already in the CSS, you don't have time to understand this big mess that you've made, you just add styles to make it work. And every time we do this, we're adding complexity to the style sheet and making it more difficult next time. And this is another big problem. We try to create design systems and style guides to help solve this problem, but the first time a designer or your design team hands you something that doesn't look like the standard components, you're in a pickle. It's a difficult situation because it takes a lot of time to build consensus, to change people's minds, to say, no, we should change a standard component. No, what happens is you just build a new thing. So how do we break the cycle? At Meetup, we made it our singular goal to write less CSS, just write less of it. And in order to do that, we first needed to frame the problem correctly. We started thinking about, like, why did we get in this mess in the first place? That's where we came up with this idea of this CSS debt cycle. And we started thinking about the developer experience. At the end of the day, it's the developer who makes the decision to add complexity to the style sheet or not, and specifically on that point in which that decision needs to be made. And of course, it's also helpful to reduce design fragmentation, but this is easier said than done. More on that in a moment. So at Meetup, we started about 2 years ago going to a utility class-based approach to styling things. This is a simple example. These are just flush classes. They remove space from an element on whatever given side. Not super impressive, but it is pretty useful. You don't have to actually open your editor to write CSS to do a very simple thing in markup. But it gets fancier. This is a flexbox abstraction with 3 classes, where row sets a flex parent, and all flex children get a class of row item. Then you can simply declare row item shrink, and that will tell that item to shrink to the content width. Here you see item 2 is just filling content. This is a more advanced example. We also have responsive classes. It follows this signature, add a specific breakpoint, modify a property in some way. Some examples, at medium, display inline block. So this is saying when the viewport reaches the medium breakpoint, set the display of this element to inline block. This sets the element's margin to auto center at the large breakpoint. And you sort of get the idea. These classes are readable, they're understandable, and most importantly, if you're going back and you're reading someone else's code, you understand roughly their intention. And this signature, this predictable naming pattern, allows us to do a number of different transforms on different breakpoints, different properties. And we found a lot of benefits in doing this. We've been doing it for a little while, and we found that it provides small, sharp tools. Each class does one thing and does it well, and it behaves the same way no matter where you put it in the document. It also allows us to rapidly prototype. It was sort of like an added bonus that we found out about, but you can assemble a layout 90% there with just classes alone without having to write any CSS. And of course, we're applying classes to markup instead of writing CSS, so that helps us achieve our goal of writing less CSS. And a predictable naming pattern in our classes allows developers to sort of style by memory. The naming pattern is really close to BEM, except less underscores because people don't like typing underscores for some reason. But presentational classes are a little bit scary. This is an article I found about a year or 2 ago by John Polasek. He was basically summarizing this methodology of writing CSS. It's a really good article, actually. But you know they say don't read the comments. Well, I read the comments, and I'm going to share some with you. This one says, there are too many class names in one element, and the class name doesn't describe the actual meaning of the content. This person may have a point. Gets a little worse from here, though. I hope this is a cruel joke that you're trying to play on people, because this sounds like the worst idea I've ever seen for CSS. You may as well be writing all your CSS with inline style tags. Okay, that person has a point too, but this one's my favorite. What's this shit? You write CSS like 5 years ago. And of course, if I had read this article before I started using utility classes, I probably would have written a comment like that too. So this is the example given in the article, and by show of hands, who feels like a little bit uncomfortable with this? And I am raising my hand. Yeah, it's a bummer. Like, it seems messy. Like, you look at this, it does feel like inline styles, and it seems hard to maintain. This should be a relief to everyone. It's a lot cleaner, it feels good, and there's nothing wrong with using CSS like this. It's the way we've done it for a while. The only issue here, though, is that you have to write styles to support that. And it's also content derived. So each new piece of content that you have to write styles for, it's a 1-to-1 ratio. So you keep writing CSS and writing CSS. And don't forget, if your goal is to write less CSS, try not to write CSS. The other issue that was brought up in the comments was the idea that this feels like inline styles. That can be true if your level of abstraction is too low. So these top examples, border top black 4 pixels, these are tough to work with because they name a specific value, which is already a disaster waiting to happen. And beyond that, they're too small, which means you need too many of them. And if you have too many of them, people aren't going to use them. But the right level of abstraction is something like text display 1 or media XL. It's not naming a specific value, but it's a concept. And where do these concepts come from? Well, they come from our design team. This is a list of just text colors, but these are also concepts. They're not just values. Like primary text is a concept that came from design, and if it makes sense for design, it will make sense for engineers. Which brings me to my next point. It's really important to foster a good relationship between design and engineering. And I won't get too much into this because there's an already amazing talk from dotCSS 2014 called Bridging the Gap Between Developers and Designers. I'm just going to pull out my 2 favorite points. It's great if design and engineering can speak the same language, and it helps foster a relationship if you have a shared sense of ownership. So this is how, well, this is just one of the ways that we're trying to do this at Meetup. This is a tool called Style Dictionary from Amazon, and it's nothing more than a build tool to transform JSON into cross-platform styles. So here's an example, going back to text colors. We define our text colors in a JSON file. The values are in RGBA arrays. And then we configure Style Dictionary to transform that into whatever we need. The real magic is right here. We define transforms. These not only tell Style Dictionary how to use the object structure of the JSON, but the property names and the actual color values into something usable. And here, we're just outputting a SAS file. And this is what it looks like. What's great is that Style Dictionary is really extensible, so you can do other things like output those same values in JSON. But what's even better is that you can use the same tool to produce your documentation. The important thing here is that when a designer wants to make sure a color is used correct, like designers want things to look good in production. When they use this tool, they have some assurance that it will become the point of truth for everyone. And I've actually been in meetings where even project managers and people not in design or tech at all will talk about primary text or inverted text, and everybody knows what we're talking about. It becomes a shared communication between everyone. And the other issue here is that this is automated. As soon as a designer or an engineer updates our colors, it appears in the documentation, and the documentation never lies to you. And static documentation is just a lie waiting to happen. If you have to manually update your documentation, chances are somebody's going to forget at some point, and the more it's out of date, the less people trust it. The less people trust it, the less everyone is going to use it, and it makes it harder to solve problems like CSS growing and growing forever. So to recap, if you want to write less CSS, it's important to frame the problem correctly. Like, recognize why humans are pretty bad at this. A lot of us think that, maybe I'm just bad at CSS, maybe my company is bad at CSS, or maybe CSS is just a flawed language and we'll try to code our way around it. But there is a human factor here that you can solve for. If designers and engineers are speaking the same language and there's a better relationship between them, you can cut a lot of the duplication issues before they ever reach your code. I highly recommend styling with utility classes. You have to do what works for you, but I can tell you that it's worked exceptionally well for Meetup. And always automate your documentation from source. All this is important because CSS is better when you write less of it. Thank you.